Hi Math 30, this is lesson 3.6, page 167. So this is the last one in this chapter. Nice word here, review. So let's start. Two cards are selected without replacement from a deck of 52 playing cards. Determine the probability that both cards are kings using the multiplication law. So probability that we're going to get a king and then a king. Well, we've got 4 kings in the deck out of 52, and then we're going to choose one of those. So here we go, and there's our king. Okay, then I've only got 3 left in the deck, and I've only got 51 cards left. So when I times those together, I'm going to get and back in goes my king. Okay, what about with combinations? Combinations, I've got 4 kings. So if I put all the 4 kings in a little pile, and then I've got a chance of 4, choose 2 of those. So let's take 2 of them. 1, 2. Oh, amazing that they're both kings, since we put only the kings in the pile so that we get what we want. So that's what we want out of a total of 52 cards that I have in the deck. Well, if I put them all back in there, let's do that, because this is a total, so there we go. 52, choose 2 of them. And that will equal the same thing, the 1 over 221. Okay, next. In a card game, you are dealt 5 cards from a pack of 52 shuffled cards. When you look at your 5 cards, what's the probability expressed in combination notation that you have? The following. So remember, 5 cards, it's going to be combinations because it doesn't matter what order you're dealt. So if I'm dealt like this, I can turn those over and then I can arrange them however I want, even though that's not how they were dealt to me. So it's still the exact same hand as the original one, or if I mix them up, like it's still the exact same hand of cards. So combinations. Now let's do it. Probability that we are dealt 4 aces. So that's probability that we have 4 aces, and probability that we have 1 not ace. So, okay, so I need my little pile of, let's take out 4 aces, and I'm going to choose all of those. 4, choose 4 for my aces. And, oh my goodness, what a miracle! Here we go, 4 aces. And then I have my other cards. So now I've got 48 of those left. 48, choose. And I know for sure I'm not going to get an ace because the aces are sitting right here. So it doesn't matter what I choose, or from where I choose that, it won't be an ace for sure. So 48, choose 1. Out of our total that we're looking for, so total cards that I could have, or total ways that I could have drawn the aces, is going to be my 52, 52, choose 5. And they don't want you to multiply it out. It's fine to just leave it there. B part, 4 tens and an ace. So now I'm going to use the same idea, and I need get my 4 tens ready in a little pile that I know for sure is tens. I need probability that I'm going to have 4 of the tens and 1 of the aces. From my little pile that I know is tens, I'm going to pick, 4, choose 4 of them. Dun, 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 dun. Oh, look at that. All 10s. How amazing. And now I'm going to take my little pile that I know is aces, and I'm going to choose an ace. So you're going to guarantee yourself that you get what you want every single time. So for choose 1 over, and here we go. Ah, an ace. Look at that. Out of, and now if I have them all back in my deck, out of 52, choose 5 that I could have done total. Okay, next one. C part, probability that I'm going to get a 10, a jack, a queen, a king, and an ace. Okay, so let's imagine this same idea. We've got our pile of 10s, and we have 4, choose 1 for the 10s. 4, choose 1 for the jacks. 4, choose 1 for the queens. 4, choose 1 for the king. And 4, choose 1 for the ace. Out of 52, 52, choose 5. Yay! And last, at least 1 jack. So we could have 1 jack, 2 jacks, 3, 4 jacks. We can't have 5 because there aren't 5 jacks in the deck. So I could do all of those separate and then add them together, or it would be easier if I did 1 minus the probability of me getting no jacks at all, because that's the opposite of here. So 1 minus probability of me getting no jacks. Well, that would be my 48 cards that aren't the jacks. I have my jacks here in a little pile. So I know that I don't have any of them in here. So I've got 48. Choose 5 of them. Out of, choose 5. Okay, see, those are so good. Okay, let's look at number 3. The word counted has been spelled using Scrabble tiles. 2 tiles are randomly chosen one at a time and placed in the order which they were chosen. So now order does matter. It's going to be permutations. Determine the probability that the tiles are C and then O. So probability of getting the C or the O, I only have one way of doing that. Out of 7 tiles total, 1, 2, 3, 4, 5, 6, 7, yeah. Choose, not choose, permute. Permute 2 of those. Okay, we had to pause for Mr. Gibbings to come watch, but he didn't want to stay, so oh well. Okay, so equals 1 over 42. Okay, now probability that both are vowels. So if I think, how many vowels do I have in this word? 1, 2, 3. So I've got 3 vowels, and I want to choose 2 of those. And I'm going to put, oh, not choose, sorry. We're going to do permute, obviously. Permute 2, because the order matters. Out of the 7 that I had, permute 2. Equals 1 out of 7. And I can also do this using fundamental counting principles, so I can do the little lines. What if I had my chances of getting a vowel and then another vowel? So chances of getting a vowel would be 3 out of 7, sorry, probability, 3 out of 7, and now I've only got 2 left in there, and I only have 6 vowels left in there, and that will also give me 1 out of 7. Here, I could have done that same chances of me getting a C. Well, I've got 1 C out of 7 letters times 1 C out of, or sorry, 1 O out of 6 letters that are left. And that would give me the 142. So on these questions, you're going to be able to do them both the fundamental counting principle or the permutations combinations way. Okay, next page. Mike's MP3 player contains 50 songs. If he listens to the 10 songs on random, determine the probability as a percentage. So this is, whoops, different. So I'll slide you down here. To the nearest hundredth that the playlist contains Mike's 2 favorite songs. So let's think. Let's get his 2 favorite songs. And notice we don't care the order that he's playing them, just that those are contained in his playlist. So we'll put his 2 songs in a pile and pick them. So 2, choose 2 times, and now we've got 48 songs left that aren't his favorite, and we need to choose 8 more. Out of, he's got 50 songs, and he's choosing 10 total. So that equals 0.03673, etc. on our calculator, and it wants it as a percentage, so equals, slide our decimal 2 places over, 3.67, which will round, oh, is that what we want? Nearest hundredth. Very good. 3.67%. Okay, what about one of his favorite songs at the beginning of the 10 songs and the other one at the end? So we're going to have one there, 1, 2, 3, 4, 5, 6, 7, 8. So this is favorite, this is favorite. Whoops. 8, and then another one for the favorite at the end. So let's get these 2 and arrange them. So we're going to do permute for that. We've got the 2 favorites. So 2 permute 2, because now we care that one is at the beginning, one is at the end. They will be different songs. Times, okay, in the middle we've still got our 48 songs left over, and now we want to permute 8 of those. And again, order matters because now we care. At the beginning, at the end, here's the playlist, and he's not putting it on random. So, well, he is putting it on random still. So that is different from this one above, because here we just want his 2 favorite songs in that playlist, and we don't actually care about where those end up. Okay, back to B part. Out of 50, permute 10 equals 0.00086 per, now change that to a percent, which equals, so move the decimal to 0.08%, which is super small. Okay, number 5. City Council consists of 9 men and 6 women. Men and women. 3 representatives are chose at random. So we need 3. What is the probability that Mayor Jim Milonovich and 2 women are chosen? So, Mayor Jim Milonovich, they are assuming, is a man. And we just need a committee. We don't care. So we need Jim out of the men, and then we need 2 women. So 1, choose 1 to get Jim, times, and now we've got 6 women, choose 2, out of 15 total, choose 3. And that's going to give us 3 out of 91. Okay, what is the probability that 2 women are chosen if Mayor Milonovich must be on the committee? Okay, so we are assigning him to be on the committee first of all. So that's 1 option out of 1. And now let's finish off. So we need the 6 women, or the 2 women out of the 6. 6, choose 2 out of, and now we don't have 15 choices. We only have 14 choices because we have to have Mayor Jim. And now we're just choosing 2 people. So now our probability will be 15 out of 91. Okay, question number 6. A hacker is attempting to break into a friend's security protected file. The friend tells the hacker all the numbers that are in the 4-digit PIN, but not the order or how many times each digit may be repeated in the PIN. Determine the probability that the hacker correctly guesses the 4-digit PIN on the first attempt if the friend tells her that the PIN contains the numbers 4, 5, 6, 7. So it's going to be those 4 numbers in any order. So 1, 2, 3, 4. So 4 choices for here, 3 choices, 2, 1. So 4 factorial arrangements possible. That would be our total number, which means we've got 1 way of guessing correctly out of a total of 4 factorial, which is 24. So we could also think about that as if we did this and the probability of guessing that right, we've got a 1 in 4 chance. Here, a 1 in 3 chance, 1 in 2, and 1 in 1. Only the numbers 4, 5, 6. So you know one of them is repeated, but you don't know which one. So you've got 4, 5, 6, and something that's either a 4, 5, 6. So what if you had a double 4? Then it would be 4 factorial ways over 2 factorial for the total number of ways. So this would be 12 ways that that could happen. What if it was the 5? Well, same. 4 factorial divided by 2 factorial ways. So 12 ways there. What if it was the 6? Oh, same, right? So we'll have another one of this. 4 factorial over 2 factorial ways. So we've got 36 ways that are possible. Only one of them will be the right PIN number. So 1 out of 36 will be the probability. And the last one, only the numbers 4 and 5. So you could have 2 4s or 3 4s. You could have 2 5s or 3 5s. And we need to do each of those cases. So if we had 4 and 4 and 5 and 5. Let's do that one. So that would be 4 factorial over 2 factorial, 2 factorial ways. What if we had 4 and 4 and 4 and 5? So that's 4 factorial over 3 factorial ways. And if we switch those over and we have the 5s, 3 of the 5s, so 4 factorial over 3 factorial ways equals a total of 14 ways, which means we're going to have a 1 in 14 chance of guessing that pin number. Only the number 4. Well, this is a nice one because it has to be 4444 for the code, which means there's only one way of getting that code. Hooray! Okay, do these super fun questions. You'll like them.